Hello, welcome to Unit 1B, which is solving equations and inequalities. Now you'll notice that we're going to pick up right where we left off after Unit 1A. So this is a continuation of what we've already learned. We're just adding a few things to it. So today we're going to learn about what an inequality is, and we're going to talk about modeling inequalities. We're not actually solving them today. We're going to get to that later on. So our objective today is to create inequalities that just model real-world situations. So let's start with what an inequality is. At the top of your page, you have a fill in the blank. It says an inequality is a statement that blank two expressions by using one of the following inequality signs, and it has all of these guys down here in your table. Okay, so what is that blank? Well, an inequality is a statement that compares. So it's compares two expressions by using one of the following inequality signs. So this one right here is the less than, but this one is the less than or equal to. So if you see the less than sign, that means that it can equal that value. If you, I'm sorry, it means that it cannot equal that value. If you see the less than or equal to, then it can equal the value. Okay, then we've got the greater than sign, the greater than or equal to sign, and then this guy right here we're not going to use very much. That's the not equal to. We won't see that too often in this class, but you might see it every so often. So now this pull tab right here is a reminder. Hold on. Sorry about that. It's a reminder from something that we've learned about in the past. So when you have inequalities, we tend to graph them on number lines, and we'll do that today. So if you have the inequality of a less than or a greater than, so there's no or equal to line here. When you graph them, we graph them as open circles. But if you have a less than or equal to or a greater than or equal to, those are closed. So we graph those as closed dots. And we're going to see that in the bottom of the first page. You can see we have some number lines. We're going to use that knowledge there. Okay, so let's look at our first example that's in context. So our first example here says that should say shopping, not showing. You are shopping for a new cell phone plan. The table represents the various plans that you can purchase. So there's 4 plans available. And within these 4 plans, we have an amount of gigabytes of data that we can use. Now you can see that the 4th plan is unlimited. So technically anybody could purchase the 4th plan, but it's also the most expensive. So if you're not going to use that many gigs of data, it would be smarter to go with one of the cheaper plans. So for our purposes, we're going to assume that we want to be the smartest when it comes to what plan to pick based off of how much money we have. So that being said, plan A is X is less than 1, that's $45. Plan B is X is between 1 and 2.5, and then C is X is between 2.5 and 4. So obviously I wouldn't want to go with plan D unless I plan on using 4 or more gigs of data throughout the month. Okay, so let's answer the following questions. Question A says, describe 2 different months of possible gigabytes of data that someone could use in plan A and not be charged any overage fees. Well, let's think about what plan A is. It says X is less than 1. Well, what are some numbers less than 1? Okay, there's a bunch of different answers I could have for this. One option would be 0. It's possible that somebody uses 0 gigabytes of data. Okay, now, not probable, but it is possible. Okay, so that's one option. Or we want two options. The second one could be, I don't know, pick a random decimal, 0.8 gigabytes of data. So less than 1, okay, but more than 0, some decimal in there. You could pick different answers for this. I just pulled those answers out of thin air. Okay, so then part B says, think back to the real number system. This inequality says X is less than 1. But is it true that all numbers less than 1 would be possible under this plan A? And hopefully you're thinking, of course not. This is a real life problem. We're talking about gigs of data. We would say no, because negative numbers don't make sense, right? No, so we cannot have negatives. Negative numbers. Okay, they don't make sense. There's also one other type of number that does not make sense. Okay, the other type of number, you remember irrational numbers, irrationals. Okay, so we can't have negative numbers or irrational numbers. Now, if you forgot what an irrational number is, it's a number that the decimal goes on, it never repeats, and it never terminates. So something like the square root of 2 is an irrational number. The square root of 2 doesn't make sense to us, not in the real world, so it wouldn't make sense in a real world concept. Okay, so we can't have negative numbers, we can't have irrational numbers. All right, so question C says, could a customer use exactly 1 gigabyte of data in plan A and pay exactly $45? Well, it says X is less than 1, so of course not, because 1 is not less than 1. That doesn't make any sense. Okay, so we would say no, because the less than symbol, put that in quotations, less than symbol, is not inclusive. Is not inclusive. So that means that 1 is not less than itself. That doesn't make any sense, right? So if you use exactly 1 gigabyte of data, you should either switch to plan B or you're going to be paying overage charges. Question D says, if we were to graph all the possible values that would work under plan A, how many points would you have to plot? Well, let's think about it. We'd have to plot 0, and then we'd have to plot all the decimals between 0 and 1, but not including 1. Well, how many decimals are there between 0 and 1? There's an infinite amount, right? Because you could have 0.1 and 0.2 and 0.3, but you could also have things like 0.11111 or 0.25673. Like, there's an infinite number of decimals. So we're going to say an infinite amount. So that being said, when we go to graph these guys, we're not going to graph them by plotting an infinite amount of points. That would take us forever, literally. Okay, so what we're going to do instead is just graph a line. So when we get down to part E here, part E has us graphing these. So we have plan A, plan B, plan C, plan D. We want to graph these on a number line, and the number line is blank. So I need to think about how to label it first off. Well, looking at plan A, it says X is less than 1, but we already talked about how it can't be negative. So I'm going to start my number line at 0. Okay, well, I know that 1 is going to be the biggest it can be, and so maybe I'll put a tick mark in here that represents 1/2 or 0.5. You really don't need that extra tick mark. Okay, so this is 1, this is 0. So since it's a less than symbol, it's not less than or equal to, on top of the 1, I'm going to put an open circle. If it had been less than or equal to, I would have filled in that circle and just put a normal point there. And since it's less than, we're going to point it in this direction. But I know that it can't go less than 0 because that doesn't make any sense. So I'm going to put a point at 0, and I'm going to go to 0, and that's it. So it's all the values between 0 and 1, but 1 is not included, which is why we have this big open circle right there. Okay, so when you're doing these on like a test or a quiz, make sure that circle is nice and big so I can see that you understand it's an open circle. Because sometimes if you draw a really small circle, it's hard for me to tell, especially if you don't have the best handwriting, so keep that in mind. Alrighty, so that being said, now we have plan B. So plan B is between 1 and 2.5. And you can see that 1 is included because it's less than or equal to right here. So I'm going to start this tick mark at 1, and I'm going to end at 2.5. And just to have a couple tick marks in between, maybe I'll call this 1.5, and I'll call this right here 2. Okay, again, that's not needed, but it looks nicer to have a couple tick marks in between. So I know that at 1, I can have exactly 1 gigabyte of data in plan B. So I'm going to put a normal point right here. But I cannot have 2.5 gigabytes of data because this is just less than, not less than or equal to. So I'm going to put a big circle there. And just like I did on plan A, I'm just going to connect these two. All right, Plan C, very similar. Starts at 2.5, ends at 4. So I'll label this 2.5, I'll label this over here a 4, maybe again put a couple tick marks in between for a 3 and a 3.5. Now, just like before, 2.5 has a less than or equal to, so that's a regular dot, regular point, but then 4 has just less than, so that's a big open circle, okay? Then we connect those together. All right, so those three are pretty similar to one another. Now look at D. D says unlimited. Well, unlimited technically means 0 or above, but we already talked about how if we weren't going to use any data, if we were going to use 0 gigs, I'm sure as heck not going to pay for Plan D. That doesn't make any sense for my budget. So I want to start Plan D when it makes sense, which is where Plan C took off from. So Plan C stopped at 4 gigs, and actually 4 wasn't even included. So I'm going to start this tick mark at 4, and then I'm going to go higher than that, 5, 6, and so on. You can put more tick marks if you want. So at 4 gigs of data, that's included. So I'm going to put a regular dot, and then instead of going to another value and connecting it, I'm just going to draw an arrow in this direction saying anything more than 4 gigs of data would be included under this plan. Okay, so this is how we graph these inequalities. Now go ahead and turn the page, and we're going to see a couple more examples that are not as extensive as the first one, so they're just a little bit quicker to go through. So question number 2 wants us to write an inequality for each situation described. And just like before, if I don't specify what variable you have to use, then you can use any variable. Okay, so I'm going to go ahead and just use the variable x for these 3 problems. But if you wanted to use something different, that's completely fine. So part A says you must be at least 48 inches tall to ride this ride. So let's talk about what at least means. If you're at least 48 inches, can you be more than 48 inches? Well, yes, of course. You can be taller. Can you be less than 48 inches? No, that's what at least means. Okay, you cannot be less than 48 inches. So if you are X and you have to be at least 48 inches, well then X has to be greater than 48. At least means bigger. But the way that this is worded implies that you could be exactly 48 inches tall. So I'm going to call this greater than or equal to 48. That represents this situation. Okay, so next one. At most, you can take 21 credit hours in college. So at most. So can I take more than 21? No, I can't. That's what at most means. So I'll use X again. So at most, you can take 21 credit hours in college. So X has to be less than 21, because less than can't be more than, right, at most. And again, it implies that it could be exactly 21. So we're going to call this less than or equal to. All right, last one here says applicants may be up to 18 years old. So they may be up to. So what does that imply? Well, they have to be 18 or younger, right? So again, if we use X, if it's up to 18 years old, X is less than or equal to 18, because again, it implies that you could be exactly 18 years old. All right, so those are some quicker examples. Now let's look at one that has a couple things going on. So question 3 is talking about Nora. It says Nora is planning a party in which she can spend no more than $50. No more than 50. She's purchasing a cake for $10 and a yet to be determined party favor at cost of C each for each of her 8 guests. Okay, so think about this. She's got $50 to spend, no more than 50. She's purchasing a cake for $10, so she's just purchasing that one time, and then she's purchasing a bunch of party favors, 8 to be exact, because there are 8 guests, okay, at C dollars each. So C is my variable in this problem, and I need to first determine which inequality symbol I should use. Less than or equal to, greater than or equal to. Okay, so, well, what do we think? it says no more than $50. So she has $50 in her pocket. She does not have any more than that. So if you think about it, she could spend exactly $50 or anything less than, right? So we're going to say less than or equal to. That's the symbol we're going to use. And the Y is, I'm just going to quote the problem, no more than. Okay, when it says no more than, that's what tells you that it's less than or equal to. So now let's figure out a scenario. Well, I know what, or an inequality, I know it's going to end with less than or equal to $50, okay, because she can't spend more than that. So let's figure out the rest of this. Well, she's purchasing a cake for $10, so purchasing that one time. Then she's adding on those party favors for 8 of her guests. So if she's going to do 8 party favors at a cost of C each, we're adding on an 8C. Okay, so that's our inequality. Now for our lesson today, we're not actually going to solve these. Some of you might be thinking, oh, I can solve for C, and that's great if you can. But for part C, we're not actually going to solve for C. We're going to determine if Nora can spend the following amounts, and we're going to do that by plugging them in for C. Okay, so this is a different way to do it. So let's start with 4. Can she spend $4 on party favors? Let's plug it in. If we had 10 plus 8 times 4, that would be plugging 4 in for C. Is that going to be less than or equal to 50? Well, let's try. We would do multiplication first. So this would be 10 plus 8 times 4 is 32. So that would equal 42 when we add those together. And is 42 less than or equal to 50? Well, yeah, of course it is. So yes, I'm going to circle number 1. She could spend $4 each on party favors. Okay, so let's try this again with 5. So 10 plus 8 times 5. Is that going to be less than or equal to 50? Well, this would be 10 plus 8 times 5 is 40, and that's exactly 50. And is 50 less than or equal to 50? Well, yes, of course it is. It is the or equal to part. So yes, this works as well. Okay, now let's try $6. And some of you are already thinking, well, if these two both work, then 6 probably won't because this was exactly 50. And you're right with that, but I'm going to plug it in anyway so you can see. So 10 plus 8 times 6. Well, that would be 10 plus 48, and that would be 58. And is 58 less than or equal to 50? No, of course it's not. Okay, so no, that's not an option. Okay, so she can spend up to $5. All right, and in our next lesson, we'll talk about how to solve these. Again, some of you might be thinking that the solving is going to be pretty similar to what we've done before, and you're absolutely correct, but we're going to save that for the next lesson. Okay, so our next question, question number 4 about Maria, that one's going to be your try it out problem. So we'll go over this tomorrow in class, and it is pretty similar to the question about Nora. So you have to come up with that inequality symbol, and model the inequality, so actually write out some sort of equation, and then you're going to plug some values in, so very similar. Okay, so we'll talk about that tomorrow.